Say it again. Oh, he doesn't want to lose, does he? Okay. So guys, listen. This is a third day of 8.1. We worked with rewriting logs in their other form on Monday. Tuesday, we solved log equations yesterday. Today, we're graphing them. Tomorrow, we'll put it all together in a worksheet review. And then Friday is a quiz, okay? This is a big, important quiz, as Evan will tell you why. Evan, why is it an important quiz? It'll drop your last quiz grade. And a lot of us didn't do great on the last quiz. And there's only been one. I've slacked a little, whatever. I've been trying to catch up. But I've only had one quiz this quarter, so some of you didn't do so great on it. So Friday's quiz, I think you're going to have no problem doing well on that quiz. So that's going to drop your other one and raise your grade, okay? So that's why we want to really make sure we take this seriously. We're at the end of the grading period, blah, blah, blah. Okay, for the parent function, it is log base b of m. Okay, remember, b is just a little subscript number, all right? So most of our graphs are going to look like that. But then you guys know we transform graphs all the time, meaning move them around. So we'll have a number sometimes in parentheses with that number and then outside to the right. We have talked about this so many times, right? The same h and k we see in a million other graphs that we graph. What direction does h move us in? You guys remember? What? Left and right, exactly. Marcus, left and right. Left and right. I think H for horizontal. And left is when we are positive and right is when we're negative. Remember, it's opposite of what you normally think. And K, I guess you guys have figured it out, will move us up or down. Up is positive, down is negative. You have to know that. You're not going to see H and K in the equation. Those are going to be replaced with numbers, right? You're going to have numbers in place of H and K. So you have to know how to tell which one it is. H will be in parentheses, K will not. That's it, okay? Then the one in that's parentheses is opposite. The steps to graph are, I'm going to write isolate, get by itself, but it's just fewer letters. Isolate the parent function. And again, if you need to write it, we're going to make sure this guy is by himself. And I'll explain all this, but if you have the steps here, you can go back and see it. The second step is rewrite in exponential, I'm abbreviating there, form. Again, I'll go over that. But I told you a lot of times working with logs, you have to rewrite it in its other form. You might be in log form and have to write it in exponential form, or you might be in exponential form and have to write it in log form. That's what we're talking about. We'll go over that. Don't worry. And then the last step is make an XY chart, then transform, meaning if there's an H and K, you'll do your little parent function with X's and we'll move them. And I will show you everything you need to know with our only 2 examples, 5 homework problems. I'm going to give you a second to catch up. No, Mandy, I don't know. Okay, you ready? So isolate the parent function. So if you look at example A, that is the parent function, log base b of m. So what I mean by that, so just look ahead at the second example. This one has some stuff added on to the parent function. So in this second example, we'll have to do step 1. But in this one, step 1, we don't have to worry about it. It's just the parent function. There's no H, there's no K. Okay, so we're going to go to step 2. Don't forget something you already know, and that is f of x means what? Y. So this is really y equals log base 6 of x. And what we're going to do is our step 2, which is rewrite it in its other form. And if you remember, we always start with our base. Wherever the base is, that's what you start with. And you do it to the power of the loner on the other side, and that will equal the last number. So when I rewrite this, it'll be 6 to the power of y equals x. Notice we have two variables here. And our exponent is a y. It looks kind of funny. But it's perfectly normal. It's what's going to happen every time. Y is always going to be your power on these problems. It's going to be different bases. There's going to be a y here. There's going to be an x there. So your parent functions are going to be 5 to the y equals x, or 2 to the y equals x, or 6 to the y equals x, or 1/2 to the y, every single time. So they're going to look really like the same. And what we do is we make our XY chart now. Now watch, guys. This is one thing that's different from any other graphs you've ever done. You're going to plug in your -2 to 2 in for y this time. -2, -1, 0, 1, 2. The same 5 numbers we use for most graphs, but you always plug in for the exponent. So you might remember the last test you guys had something to the power of x. We plugged in for x on those problems. Here you plug in for y. And I think you'll catch your mistake if you forget, because if you put a -2 in here, how would you solve for y, right? So 6 to the y equals -2, what would you do? There's no way to solve that, okay? So this, we're just going to go through and put it in our calculator. You know what? I hate this calculator. It's nice because with graphing you can see the different colors and it's faster, but this screen shows up better here. Okay, so I'm going to do 6 to the power of -2. You can totally leave it as a decimal. Make it 0.03 if you want to, or change it to a fraction. I don't care. It does not matter which one you use, okay? So for one, I'll use a fraction. For one, I'll use a decimal. So I'll just use 0.03. Guys, the point is it's a teeny tiny itty bitty baby number. It's tiny, okay? It's less than 1, okay? And I'm going to keep going through the XY chart. 6 to the power of -1 is 0.17. Another really tiny number. Who cares, right? It's less than 1. It's hard to graph. We do the best we can. Anything to the 0 power is 1. I'll prove it to you. So there's that intercept. And then 6 to the first power, I don't need a calculator for that. And 6 to the second power is 36. So use your calculator, fill out your XY chart. Okay, I'm going to have to do this one on the next page. I don't ever give myself enough time. Okay, so I'm going to graph it. Okay, so to the right a teeny tiny bit, down 2. Right, a teeny tiny bit, down 2. And I'm going to go ahead and make these my final points, because I don't have an H or a K, so I'm not going to have to move my points anywhere. Okay, so this is going to be my final graph right here, so I'm not going to use X's. To the right a tiny bit more, down -1. 1, 0 would be here. 1, 2, 3, 4, 5, 6, 1 would be here. And 36, 2 is way that way. Please, let's not waste my graph paper to do that. Just like we did with exponentials, just put it, somewhere down there and label it. Just tell me you know that that's not actually to the right 36 up 2. We're just conserving paper. And your asymptote, remember we had asymptotes in exponential functions? We also have asymptotes in log functions. Your asymptote is right here. It doesn't touch, that's right. It's a vertical line, so it's a vertical asymptote is what we say, VA. And it's a line, so you have to call it x equals whatever the number is. So I remember it by saying vax, like a vaccination. Vertical lines are always x. Okay? So that's, most of your homework is that type. Number 31, your last one, and definitely on your quiz, we have some like this one. So I'm going to rewrite this on another piece of paper because I can't fit it. So example B. So in this one, we have some movement, okay? So remember step 1 is to isolate the parent function. Guys, that's everything up to x. Leave h and k out of your xy chart, okay? So I'm going to go ahead on to step 2, which is to rewrite this log in exponential form. Remember, you always start with your base, wherever it is, no matter what side of the equation. Don't let that throw you off. 3 to the y equals x. That's the only part that gets in the xy chart. 3 to the y equals x. And we make an xy chart, plug into y. And what's nice about these calculators, you can save yourself some time. You don't have to do one at a time. Do a few at a time. A few answers will fit in here. Like 3 to the negative 2, if you want to write it as a decimal. If you want to write it as a fraction, there's 1/9. 3 to the negative 1. Math, enter, enter. Oh, I lost the top one. 1/9 was that one. 1/3. Anything to the 0 power is 1. 3 to the first power is 3. 3 to the second power is 9. There's our starting points. Make x's. Graph those with x's. Because we have to deal with 1 and negative 4 in a minute, okay? So, say it again. Nope, you could have done that. Decimals or fractions there. The whole point is your first few are always going to be itty bitty teeny tiny baby numbers. So to the right a teeny tiny itty bit, down 2. Notice x's. To the right 1/3, down 1. 1, 0. 3, 1. And I think I can fit this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now I'm not going to connect them, because that's not my final graph. It gets a little messy. I'm going to move all my points what direction? What does the +1 do to all my points? Left 1, right? It's always opposite in the parentheses. Left is positive, negative is right. What is -4?
Down.
Down, right, JT? Down 4. So I'm literally just going to take each of these points and go right 1, down 4, right 1, down 4, okay? Now, we have a new asymptote. Since we're talking about vertical, it's the h that gives it to us. You're actually going to have a new, well, let's go ahead and put the ones in. Left 1, 1, 2, 3, 4. Left 1. So your I didn't mean to. Stop yelling at me. Why'd you yell at me, Sarah? And over there. Somebody yelled at me over there, too. Remind me. It was you. Gosh, you guys are so mean. I don't yell at you when you make mistakes. Okay. So that left one, think. Your asymptote on the parent function is right here. Where is it going to move? Since we move left 1, it moves left 1. It moves your asymptote is going to move left or right according to your h. So remember I said sometimes it helps to put it in there. It guides you, not for these points. Left 1, 1, 2, 3, 4. Left 1, 1, 2. You better be going left. Left 1, 1, 2, 3, 4. Okay, so those first 3 points are always so easy. Then you get these little decimal-y ones. Do the best you can. Like, you kind of get to the point where you just, you know where they're going to be. You just know you can't cross that asymptote. So we have a vertical asymptote at x equals -1. And there it is. And we got it from h. H is your asymptote. Okay? I'm going to come around and give you guys some graph paper. You should have no problem fitting 5 graphs on Not when I'm giving it out for free. Okay. So, homework. Oh my gosh. I'm trying to rush for you guys, so. Where's the page? Grade B. Can't find it. Oh well. Okay. Number 24. Yep. 59. If you don't have the page and you're working ahead, here's the first two. Look at those yucky little bases, those little fractions. That's okay, we can handle it. We have a calculator. When there's no H or K, this is what you're asking, Evan. 1/9, yep. When there's no H or K, your vertical asymptote is just x equals 0. When there's something in parentheses with the x, that will move your asymptote left and right, and then you'll have one. Like you'll see in number 31. So I'm going to rewrite this in its other form. Base of 1/9 to the power of y equals x. It should always look like that. Some number to the power of y equals x. Okay? Always, always. And then we'll make an xy chart. Always the same 5 numbers, always plugging in for y. Okay? So how do I put 1/9 in? This is important. I'm pretty sure you have to put it in parentheses. 1/9 to the power of -2. And you get 81. 1/9 to the power of -1. When I put that in my calculator, I would get 9, 1, 1/9, and 1/81. And of course, you could make those decimals if you want to. Doesn't matter. So what happens when our base is big like this? I'm sorry, when our base is small, you'll see right here. It's really weird, actually. I'm actually going to start here. It doesn't matter what side you start on. There's arrows on both ends, so it doesn't really matter. To the right, 181st. Where the heck is that? Who knows? Who cares? But we go up 2. See the difference? To the right a little bit more, up 1, 1, 0. 1, 0 will always be on your parent function. To the right, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, down 1. And who the heck, we're not doing that. That would be to the right, 81, down 2. That's what this point would be. And you could have graphed it in that order, the other order, it doesn't matter. But you can see it changes the shape of the graph. Arrows on both ends. Our asymptote, which we want to list, it's a vertical. They're always vertical. They're always going to be x equal whatever the h value is. H is 0, but we don't have one. So our asymptote is right here. Okay? I think you guys can handle these. I have all the work shown. So here's 24. So in a few minutes when people finish 25, I'll be able to fit all of them up here. That's the best I can do at the moment. Don't yell at me again. this is. When Tyson comes back, yeah. Are we done with 25? Are you done with 25? 25 done? I really can't put them all, can I? Nope, sure can't.